vocabulary words today. So, typically when I teach something, I'll have a good portion of the student population has some knowledge of this. You guys don't know any of this. So this is all brand new vocabulary words. So unfortunately for me, a section on vocabulary words is usually pretty boring, and I'll try to make it as interesting as possible. But it is what it is. It's a lot of vocabulary words. We will be using these vocabulary words throughout the rest of the chapter. So it is critical that you understand these vocabulary words. They're not that complicated. The issue is that it's new. So you haven't had these vocabulary words before. So for the kid that only puts a little bit of attention, it's hard. The second thing is we're doing a lot of drawing today. Okay. No, most people don't get it right the first time. It's fine. Okay. But please give it your best shot. Here we go. Homework, write down. Jake, what's your question? Yes. Are you turning this in late? There's nothing.
Yeah, I haven't done it yet.
All right. Hey, I did say I did grade the quiz. Everyone was here. It's the other class that have 2 absences. They're going to take it. Upper school has not you guys, future high school students next year. That's 8th through 10th. We're going to have a meeting during student advisement. You guys are going to be going to Miss Emmons' classroom for student advisement. So the history classroom. Today.
No.
I literally just said why. Clearly. You don't know it yet, but when you get to high school, teachers don't choose your classes. You choose your classes. Okay. So that process of choosing your classes happens somewhere close to spring break. We're about 2.5 weeks out. Jake, stop. We're about 2.5 weeks out. So this is usually when we have a big meeting with all the high school students and say, here are your classes for next year. Pick which ones do you want to take? That sort of thing. You don't choose all of your classes, but you choose your elective classes. And we don't tell you you have to take art, music. You get to pick. But that'll be next year or 2 years from now for you guys when you get to high school. All right, here we go. A word that you have never seen before, never heard of before. The rest of the chapter deals with these things. All right, here we go. Lots of definitions. The end of chapter quarter 1, beginning of second, we were in second quarter. We were in chapter 4. Chapter 4 was we dealt a little bit with geometry things. We talked about these things called polygons. Don't write this one down. Polygon means poly meaning many, gon meaning corners or angles. It's a shape that has many corners or angles. Those are your triangles, your trapezoids, your octagons. Closed plane figure, that means that it's closed. There's no opening to get to the inside. Plane means that it's on a flat surface, a plane, and it's made up of segments. And if you remember the class, I gave you 3 different size segments or 3 segments, and I said make a shape with them. Well, here's a shape that I make with them. Why isn't this clicking? Oh, I know why. Here's a shape that you make with them. It is an unrecognizable shape because I didn't follow the instructions. The instruction says the segments are joined at their end points. If instead I join those segments at their end points, I make a recognizable shape, a triangle in this case. And our first part of the chapter is dealing with areas of polygons and circles. So, plane figure means that it's 2 dimensions. Now, I used to always throw this word out, 2 dimensions, and I literally would have kids come up to me and say, I don't know what that means. All right, 2 dimensions means this. First off, the 2 stands for 2D for dimensions. Secondly, that means that the dimensions are, well, it's left, right, up, and down. It means if you can draw the shape, either drawing left, right, or up and down, those are the only directions that you can go, well, then you've made a 2-dimensional object. For instance, a circle. I can only go left and right or up and down. I can make a circle using those. I can also make a square if I go left, right, or up and down. But what I can't make is a cat, right? Because a cat actually has a 3rd dimension, and that 3rd dimension Well, it doesn't go left, right, or up or down. It goes in and out. Okay. So an object that's in 2 dimensions, well, it looks like that. It's flat. Objects that are in 3 dimensions, right? That's what we're doing for the rest of the chapter, 3D objects, has a 3rd dimensions. But here's the problem. I'm still going to draw this either on a piece of paper or on the board. You can't draw 3 dimensions. The board is flat. So what they do is they don't really make a 3D object. They make a simulated 3D object. And here is the biggest problem with the rest of the chapter. They don't actually have a 3D object like what I have in my hand right here. They draw this on a flat surface, and then therefore it doesn't look exactly right. So here's how they do it. Instead of having the real 3rd dimension, watch me, there's the 3rd dimension. It comes out from the center. What they do is they take this, because they got to draw it, and they turn it sideways. And it looks sort of right, but what it's representing is that this is coming strictly out at you. This is your 3rd dimension, okay, in and out. Okay, but the way they draw it is like that. The part that goes behind, they make dashed. The part that goes in front, they make solid. It's not really 3 dimensions, it's 2 dimensions. You'll see when we start drawing, especially these ones that involve triangles, it messes with your eyeball. Some people don't even see them correctly. I'll try to help you with that. First word from the Greek, poly means many, hedron means face. An object that has a lot of faces is called a polyhedron. It's still going to be closed. These are all polyhedrons. It's still going to be closed, meaning like there's no opening to get to the inside. It's closed. It's made up of polygons. So this one's made up of hexagons and rectangles. And those hexagons and rectangles come together at their sides, except it doesn't say sides, it says edges. You took a whole bunch of pieces of paper and joined them together along their edges, you could make a polyhedron. Okay? Poly means many, hedron means faces. So here's the problem. The problem child shape is the box. The box is great, and this is a real box, right? 3 dimensions. And there's no problem with this. The problem with this is drawing this. First off, this is made up of what shapes?
Squares.
How about we just say rectangles, right? Squares are rectangles. It's made up of rectangles. If you draw rectangles on a flat surface, it doesn't look like a box. So here's the paradox. To draw a box in 2 dimensions, flat surface, we don't draw rectangles, we draw parallelograms. Watch me. That's not a rectangle, that's a parallelogram, okay? That represents the top of this box. But notice, top of this box is an actual rectangle. That ain't a rectangle, that's a parallelogram.
It could look like if you're facing it that way.
It will not look right if you actually draw literally a rectangle. It will look, well, that doesn't look right. So we draw a parallelogram to represent the top. We draw a parallelogram to represent the bottom. We draw a parallelogram to represent the left side. By the way, it's not a parallelogram, it's an honest to God rectangle. We draw a parallelogram to represent the right side. The only rectangles you actually draw are the front and the back. The front is literally a rectangle, the back is literally. When you push those pieces together, join them at the edges, you make a, push them together, what do you make?
A box.
You make a box. So here is my box all together, right? Cool. You want to know the issue in 7th grade is you got to draw that. So we'll do a little bit of practice drawing those things. So we'll be doing this thing with polyhedrons. Polyhedrons come in many different, just like polygons, triangles, trapezoids, octagons. Polyhedrons come in lots of different flavors. Okay, this is one of the flavors, a box, except we'll give it a better name here in a second. You got that shape, which is clearly a, some people don't know that. Triangles are 2 dimensions. There's no triangle here. It's a pyramid. Some of you know the shape. That's a
Hexagon. Like a cylinder.
Well, it's got a pentagon. It's Pentagon.
Pentagon thing that's like a
Octahedron.
Okay.
Octahedron.
Anybody play D&D? You know, you got all these dice. Those are all polyhedrons.
Oh, okay.
Those are all polyhedrons. The rest of the chapter deals with these shapes and their volume. Okay. There are shapes though that are not polyhedrons. Here's one. Why is this not a polyhedron?
Because it doesn't have a.
There's no polygons here. Circle is not a polygon. Well, this side of it, well, it's not made up of polygons. It's curved surface. So this isn't a polyhedron. What else?
A sphere.
Sphere. What else?
Cylinder.
Those are your three that are not, that we'll see this year. The cylinder, the cone, and the sphere. They are a 3D shape for sure. They're just not polyhedrons. Okay. Polyhedrons have to be made up of polygons. Okay. All right. So here we go. The hardest thing today is simply draw these suckers. So let me show you how it's done first. Watch me. So the first one we'll do is we'll draw one of the hardest ones, the box.
Wait, is
Okay.
this just the hard?
Yes. But there's other parts to it.
There's nothing.
Okay. So to draw the box, you draw. Now you can start anywhere. I generally start at the top. To draw the top, you don't draw the top as really a rectangle. You're like, well, that's a square. Okay, squares are rectangles. You don't draw a rectangle, you draw a parallelogram. Underneath of it, exactly the same shape, but underneath of it, you draw a second one. And then what you do is you connect the corners. I connect the four corners. But wait a minute, I wouldn't see this corner if it was like this. We make it dashed. I also wouldn't see this side, this edge, and that edge. So I make them dashed as well. There's your box. As I said, when you draw this in 2 dimensions, some people, when they see the box, it's like this. Other people, when they look at the box, it looks like this. It doesn't matter whether it looks like this or it looks like this. It's the same box. Can anybody see this?
See both of them.
Some people see both of them and it flips back and forth like quickly in their eyes. It's hard. Some people see this. Literally, they're seeing this. Other people see this. And that's the problem with drawing 3 dimensions in 2 dimensions. Okay. Let's draw it. Here we go. Box number 2. Let's draw one. So the steps were, let me go back. Draw me a parallelogram. Draw a parallelogram. Box 2. Draw me a parallelogram. Underneath of it, you got to make it exactly the same size. Draw a second one and I'll pause. So now I have 2 parallelograms. Once you have your 2 parallelograms, join up the corners. Join up the corners. The one that you wouldn't see, make it dashed. And you got yourself a box that we still haven't given a correct name to.
Cube?
Well, it would be a cube if you made it with squares.
That's not a box.
Yeah, that's perfect. That's perfect. That one's well done.
It looks terrible.
All right. Everybody done? There are parts to a box. There are parts to a polyhedron. These are the common terms. Now, we're going to give this a name here in a second, but there are common terms to polyhedrons. So these are the common parts. All polyhedrons, also in box 2, have the corners, except we don't call them corners. We call them vertices. We had that in triangles as well, too, the vertex. Vertex 1, plural vertices. So all boxes have corners, label, box, label, box 2. Connect them. All polyhedrons have vertices. All polyhedrons have where the polygons come together, the edges. You can think of this as a knife, the edge of the knife, right? Okay. Ouch. And all polyhedrons have the faces. Whoops, sorry. Have the faces. Faces is a side of a polyhedron. Those 3 things are on all polyhedrons, right? Here are 2 completely different polyhedrons. They all have these 3 parts. They all have faces, sides. They all have vertices, corners, and they all have edges. Okay? There's some other critical parts to them, parts that are red here, green. We'll give these names when we talk about the name of this box and the name of this thing, right? Which we already know this one is a What's the name of this one? Anybody? Not the math word. Does anybody actually know the name of this? This is certainly not a cube.
I think I used to know it, but
Okay, we'll see.
doesn't it start with
It does. Okay. So now we're going to go ahead.
Did you ask what the shape of that box is?
Yeah, what is it?
Is it a rectangular prism?
Yes. Thank you. All right, one person knew. All right. So now we're going to give names to this. We'll start off because everybody likes the box. The box is actually the hardest one. It's the hardest to draw, and it's also the hardest to remember the parts to it. And it's because all the sides are, no, that'd be a cube. All the sides are, they're all rectangles, right? Each side is a rectangle. Notice when we get to a pyramid, the sides are actually different. But on a box, all the sides, not the same area, but the same shape. They're all rectangles. So here we go. The first shape we'll deal with is that one. Richard already called it a what? A rectangular prism. I'm not going to draw that one. I'm going to start off with this one. This is not a tent. Some teachers like to say tent, and that's simply because they want you to differentiate this with a no. With a, some people see this and they think this or vice versa. These are not the same shapes.
Wait.
And that's why a lot of teachers, not me, but they'll say this tent, not tent. Okay, this is
That just that without an extra side.
agree, but it makes a completely different shape. So, hey, box 3, draw this, please. We're going to start off with a kind of a squish triangle. Box 3.
Oh geez.
Okay, draw a triangle. And then just like the box, underneath of it, we're going to draw the exact same thing. And then guess what? Connect the vertices. So we connect the vertices and we get to our first one. Now, here we go, eyeball flipping people. Some people see this. Some people see this. Some people see where this is coming out at you. Some people see where the flat side is coming, and it'll go backwards and forwards with you.
I see what
Hey. All right,
it's just teeth.
here we go. This shape, Richard is called a
Triangular prism.
So here was my issue in 7th grade. I heard the teacher say this, and all I heard was the word prism. And my mind said, wait a minute, I've seen this before in,
Jail.
I've seen this before in science class. In science class, my teacher took this and did what? And what happened? And it made a rainbow, literally. If you take this shape, made of glass, and you shine a white light through it, out the other side comes a rainbow, literally. And so all I heard was the word prism, and I saw this shape because my teacher did the same thing. The first one, they started with this one, and that locked in my brain, and it caused me big problems. A prism is not this. This is an example of a prism. There are lots of prisms. Okay, this one is called a prism. Right. Box 3. A prism. Well, it's a polyhedron. Two of the faces are the same shape, and they're parallel to each other. Two of them, in this case, the two triangles. But it doesn't have to be a triangle. I should stop for a second, look up here. What's the shape? How many do I have?
2.
Two of the faces are the same. The rest are rectangles. A prism is when you have two of something that are the same, congruent, same size, same shape, and the rest are rectangles. My problem was I didn't hear my teacher said that. I just saw a prism. Oh yeah, science class, rainbows. And I thought this was a prism. This is an example of one type of prism. Prisms come in lots of flavors. By the way, guess what the box is? It's a prism. This is why I never got this, because I heard prism and I thought rainbow, triangles, right? Boxes are prism. It's got two sides that are the same and they're parallel, and the rest of it is rectangles. Boxes are prisms. This sucker is a prism. And where'd my other one go? This one is also prism. The way you identify prisms is you look for rectangles. If you see more than 2 rectangles, that sucker's a prism. You see more than 2 rectangles, it is a prism. For 7th grade at least. Okay.
It gets harder.
Well, we can have 2 or more prisms and not be a prism as well too, but not in 7th and 8th grade. All right. The thing that you look for are the rectangles. If you got more than 2 rectangles, it's a prism this year. Okay. So that is called a triangular prism because we're going to call them bases here in a second. The bases are triangles. Okay? All right. Box 4, draw me another triangular prism one more time. Triangular prism. Draw your first triangle. Make it kind of squished.
It looks like a square.
Draw a triangle, not a rectangle.
Like a square.
3 sides, not 4. Underneath of that, draw the same triangle. And then connect the edge or connect the vertices. Jake.
I don't like that. I keep seeing it like.
I told you, this will cause a problem. My shapes that I will have here, when we get to test day, will be on the bookshelf. If you want to grab it and bring it to your desk, the shape that you're dealing with, so your eyeball doesn't flip around, be my guest. Okay, those don't break my shapes. All right, this one is called a triangular prism. We're going to draw 3 of these. Okay, this one is called a triangular prism. The 2 things that are the same are the triangles. Notice there's 2 triangles. There's 3 rectangles. 3 or more rectangles, it's a prism. The next one I'll draw is the box. Well, the box has got certainly 2 rectangles, but the sides are all rectangles. This one's got 6 rectangles. It has nothing but rectangles. It's a prism. The problem with a box is that you can turn it sideways. And now the bases become, well, any 2 sides can be the bases. Triangular prism where the bases are the triangles. The more challenging one I want you to draw here is a pentagon. Draw me a pentagon. Squish it. Like it's not tall and
I don't
regular.
know how to draw the rectangle. How come we can't draw like that? Oh yes, I do. I just did it.
This is perfectly well drawn, but I want more than just the triangular one. Okay. This is perfectly fine as well too. That's just the triangular prism on its side. That's where people see tent, right? But this thing has to go all the way to there. This thing has to go all the way to there. There you go. Now those look better.
It's still cheap. How do you draw that?
Okay, underneath the pentagon, draw another pentagon.
How do you draw that?
It's got 5 sides.
Okay.
Okay, how do you draw it?
Yeah. Same way you draw
Okay,
that.
I draw a inverted V.
Wait, whoa. Draw a
And then it comes in, and then connect. All right, once you have your 2 pentagons drawn, then you connect the vertices, and you have, what's this one called? What's this one called?
a circle.
If this is a triangular prism, this is a rectangular prism, this would be a pentagonal prism.
What?
There is no end to these. These never stop. You got octagonal, heptagonal, septagonal, dodecagonal.
Why is it all hexagonal? Why isn't it like
All right. Of these 3, I throw this one in there just for grins, but those 2 you will see this year, triangular and rectangular. You also see a cube. Cube is not a math term. We will use the word cube. A cube is still a square prism, right? We have another term for it here. We'll get today as well too. All right, so this is what Maddie said. She said you can take a triangular prism, or any prism for that matter, and tilt it sideways.
now it's cheap?
Sorry. If you tilt it sideways, the 2 bases are now left and right, not top and bottom. It's still a prism. So to draw it on its side, well, you draw your 2 triangles left and right.
You draw a parallelogram. That's what I did.
There's no parallelogram. You draw your 2 triangles first. Draw your 2 triangles first. And then connect the vertices.
I do not know how to draw this.
We won't draw the other ones on their sides, but they would be drawn the same way. If you draw your 2 parallel sides left and right first, Yeah, I don't like to stare at the screen too long for this because all it does is start flipping around on me and I
If you
run into
look at the
problems.
one I drew, you can't see the top of it.
Okay.
But then if you look at that one, you can see the top of it. I'm like, wait,
Depending on how you drew it. Because this could be canted back like this and then you wouldn't see the top.
it's all about your perspective.
It is. All right. I call this one my problem child. My problem child is this. It's really easy to see the two bases, right? Two bases of the triangle, two bases are the pentagons. For a box, any two sides that are opposite each other could be the bases. So this one is challenging because I'll say, well, what's the base? And you'll say, well, which side do you want to be the base? So you have to have some common speak between the two people that are
Can it
talking.
be any side?
It could be any side and its opposite side could be the basis.
Okay, so it's like the what was the other side you had that could that any well not any two bases could be a
Well,
base.
remember, for a triangle based on side, any side could be a base.
So both any of the sides can be a base, but you have to
For
you
the
guys
rectangular
swap that
prism.
to
For
around.
triangle and any other prisms, then the two parallel sides are your bases. Okay, but rectangular prism have 4 sets of parallel sides. All right.
I like
Looking at it.
All right, parts of a prism. One more time. Box 5. Yes, I'm making you draw this. So you got to draw these things. Box 5. Draw me a triangular prism. If you want to turn on its side, you can.
Oh my god, I cannot draw this.
This is why we're practicing.
But it's not our class.
Polyhedrons all have the same 3 things. They all have faces, they all have edges, and they all have vertices. The specific parts of a prism are going to be the bases. The bases are the 2 parallel sides. So for a triangular prism, they make these colored. This one's yellow. The 2 triangles are your bases. But look at me. Is this a prism right now?
Yeah.
If I turn it sideways, is it a prism?
Yes.
It doesn't matter which way it's turned, it's still a prism. What matters is where the bases are. If I turn it sideways, the triangles are still the bases. For a triangular prism, the bases are the 2 triangles. For any prism, the 2 parallel sides. The problem child is the box. Because look, no matter which way I turn it, you have 2 parallel sides. So it doesn't matter which side is the base on your rectangular or triangular prism, the box.
So how is it a problem child? It's more like a
Because when I say what's the base, well, it could be any one of the 6 sides
yeah, could you
is the
highlight it for us?
base. What?
Could you, when you're on the test or whatever, could you highlight it for us? Like highlight
And that's going to be my recommendation is that when you, well, I'm still going to ask you to do a calculation. You're going to have to use the base. So what I always recommend is to shade which side you're using as the base. Okay. All right. So those are the only unique parts of a prism are the bases. We still have those other 3 things: bases, edges, and vertices. We okay? I don't label the parts, but just so you remember, we got vertices, we got edges, and we got faces. We okay? That's all we're going to do in box 5. Problem child. It's not, I mean, it's actually the easiest one to calculate. It's just that we run into problem when people say, well, what's the base? Well, any side could be the base. On a triangular one, triangle has to be the base. All right, these have names, right? We called this the, oh wait, what did we call it, eh? Clearly not a prism. How do you know this one's not a prism?
because there's not a triangle on this side.
Because here is a prism, here's not a prism. Danny, what's the side on prisms? What's the side on pyramids? The triangles. If you see triangles, you got a pyramid. Now be careful, right? Because also you have triangular prisms have triangles, but check it out, the sides are rectangles. Sides of this are only triangles. And that's what makes a pyramid. Let's write that one down. Oh, how to draw it. Okay, how to draw a pyramid, box 6. Draw me a triangle. Put a dot directly over the middle, wherever you want, but it's going to be over the middle. And then from the middle, connect the vertices. Yeah.
Couldn't you just draw lines with each of them until they meet?
What do you mean?
Couldn't you just draw lines at a certain angle until they meet?
Well, depending upon if you want a specific pyramid. I want a pyramid to where the angles formed are, well, it's got to be less than 90, right? All right, that's called a pyramid. It's a polyhedron whose faces all intersect each other at a point. All the faces come together to one point.
Oh, that's so trippy now. I'm imagining it like you're seeing one side here, but then it goes.
Oh, don't do that. You're going to give people headaches. So some people see this. Some people see this.
Or turn it like so you're looking at the bottom. Like
Don't do it. You're going to cause people headaches.
I think it's cool. So
This is the one that really, if there's one that I don't want to ever look at, it's this one.
Why?
I can't look at any of them. without
Because
getting
it just flips around on me too much. So I don't, if I'm going to actually draw this, I don't even draw that. I just shade, right? So for instance, if I were to draw this, I would draw something that looked like that, and I would leave it at that. Okay? I wouldn't play this because then when I put this other line right here, that's what causes me problems.
Oh no! Yes, stop.
But if I leave it like that, then my eye's okay. The issue is that to calculate the things that we're going to calculate, we have to have those sides drawn. All right, that's a pyramid. The note here is that all the sides are triangles. Notice I didn't say base, I said the sides. The base could be actually any polygon. There are octagonal pyramids. We're more familiar with what kind of pyramids?
The pyramids in the desert.
So what kind are they?
I don't know.
Take a guess. What kind are they?
Egyptian ones made out of sand and lime.
What kind are they? And why am I pointing this at you?
Egyptian ones.
What kind are they?
They
They're called square pyramids because the bottom is square. But be careful. Is this a pyramid?
Yes.
Is this a pyramid?
No. Yes. That is a piece
What?
of cheese.
Just because I turned it, it's not a pyramid? It is a pyramid no matter which way. It's still a pyramid. It's upside down. The issue is this. The issue is that the base of a pyramid is always well, it's not the bottom because if I turn it upside down, it's not the bottom now. The base is this part where the sides all come from. That's where the base is. It could be a square pyramid. It could also be a triangle called triangular pyramid. These are still pyramids. The sides are triangles. One, the base is a triangle. One, the base is a square. Square pyramid, we as humans find the most pleasing. That's why you'll find them in Mexico. You'll find them in Asia. You'll find them in Egypt, of course. You find them in the United States. We have pyramids. They're called mounds. They didn't build them out of rocks. They built them out of dirt. We do. In fact, in Colorado, we have a mountain that's literally called Pyramid Mountain because it's shaped like a pyramid. All right, drawing pyramids. Once again, box 7, one more time. Draw a squished triangle. Draw this, please. Directly above the middle, somewhere. If you draw it really high, it's a tall, skinny one. You better stop. You can either draw the dot way far above, it'll make it tall, or you can put it closer to the triangle and make it squat.
Make it squat.
That's what squat means. This is a pyramid. It's where it says drawing pyramid. I said today we're doing a lot of drawing.
Of the same shape multiple times?
Yes.
That makes no sense. Wait, is this a square one?
All right.
I need to look
The
at
one that we just drew is called a triangular pyramid because the base, just be careful, don't say the bottom, but because the base is a triangle, but there's other ones. All right. Also in box 7, draw me a parallelogram. The parallelogram is going to represent a square. Like, well, why don't I draw? If you draw a square, it doesn't look right. So we're going to draw a parallelogram. Directly above the middle, put a dot. Now connect the dot to the 4 vertices, and you have now made a square pyramid or a rectangular pyramid.
What is this? What is what?
You have now made a rectangular pyramid. Now, we can properly call it square if we made a square.
This makes me sad.
Okay.
This is giving me a headache.
Well, for the prism, not for the pyramid, though. We make pyramids out of discs, and we make them out of.
And so is that like a trap?
We could make a trapezoidal pyramid. So draw me a trapezoid. put a dot directly above it, play connecting, and now you made a trapezoidal pyramid.
I don't like that. You are killing.
All right.
Cool.
You can draw any polygon. The one thing you can't draw is a circle, because if you make a circle, guess what you're actually making? You're making a cone.
You can even do like a.
You can. Pentagonal pyramid, yeah.
Really?
I'll show you a picture one if you like. There's a big one in France.
I'm gonna make one. Is it the Eiffel Tower?
Eiffel Tower is basically a pyramid that's curved, right? It's a rectangular pyramid. It's curved. The sides, the legs are curved, but it is absolutely a pyramidal shape. All right, box 8. Draw me a pyramid of your own choice.
I thought there was a lot of definitions.
What?
What words?
Well, for the people that actually wrote them down, there were.
I did.
Okay. Draw me up another pyramid, box 8 of your choice.
That's weird.
I drew a triangular pyramid. We got a couple words.
Let me do what you did. Okay.
Maddie drew a hexagonal pyramid. Very nice.
I did.
It's got six sides on its base.
That's what I did. I know what that is.
All right. The parts of a pyramid. Remember, pyramid's a polyhedron, so we still have faces, we still have edges, and we still have vertices. I don't want to say bottom, but where the faces or the sides of it come from is called the base. I can take a pyramid and turn it to its side, and the base is still there, it's just in a different orientation. Okay? Be careful with that. The base is not what it rests on. Jake, write this down, please. Okay. The top, where the faces or the sides of it come together, is called the vertex. You're like, well, that's the same thing, polyhedron. Yeah, we say a pyramid, though, has a definitive vertex. There's vertices to all the polyhedron, but when we talk about the vertex of the pyramid, we are talking about where the sides of those faces come together at a point. The vertex. Okay, turn around, please.
Wait, can't the base be any side though?
Not only for boxes. For a pyramid, that's why this is colored. The pyramid, it has to be where the sides come from. Because if I turn it like this, the bottom is not the base. This is still the base. All right, here we go. We love talking about these kinds of polyhedrons. These are called, box 9, right? This regular polyhedrons. Regular polyhedrons are when all the sides, the faces, are exactly the same. I mean, the same shape. And they're congruent. We call these regular polyhedrons. These are the 3D shapes that when we draw what we would like it to look like. Turns out there are 5 main, well, there's more than 5. There's 5 of them. These were, believe it or not, the Greeks are the ones that came up with these ideas, and a guy named, you probably heard of him before, Plato. He's the guy that gave them names. He called these his solids, and he called these his Platonic solids. Plato, Platonic. Okay, these are the sides. So, well, let's see. What would be the first one? The first one would be if you could make a shape of nothing but triangles that were all congruent. What would that shape be? If you made a shape of nothing but triangles, and all the triangles are exactly the same size, what would that be? Be this thing. All the triangles are exactly the same size, right?
You're gonna drop that on my
We call this, write this down, you don't need to draw the shape. We call this a tetra. Tetra means 4, there's 4 sides. Tetrahedron. Tetris is called Tetris because there's 4 shapes. You got it written down, Jake? The first Platonic solid is called a tetrahedron. Every year when they do the balloon launch, there's always the tetrahedron balloon.
I went to the balloon launch and it was very disappointing.
Every September at Memorial Park, they launch about, I don't know, 40, 50 balloons.
It's pretty, but they did it too late.
But they
so
do
I
it
couldn't
at
see
7 o'clock in the morning, so you got to get up really early.
I
All right.
the night
The next one, yeah, that's called balloon goat. The next one is the one that everyone's familiar with. It's the cube. Okay, that's made up of 6 sides, but all 6 sides are exactly the same shape. You can't make it with triangles. You have to make it with squares.
Can you make one rectangles? Wait, no, you can't.
Well, the rectangles will not all be the same size. Now, considering that a rectangle is, or square is a rectangle, then I guess you could argue that this is made with rectangles.
Well, not really.
Okay. The next one really jumps up. 8. If you take a couple of these together, right, you put them together, you can make what's called an octahedron. And that's taking I grabbed the wrong one. I was supposed to grab this one. You grab a square pyramid where all 4 of these triangles are the same. You put 2 of these together, then all of the faces are exactly the same size. You make what's called an octahedron. 8 sides, they're all triangles, and they're all equilateral triangles. Caitlin, you got these written down? The next one is made of pentagons. It literally takes 12 pentagons put together to make this shape. But it's made of nothing but pentagons. It's called a dodeca. Deca means 10. Do means 2. 2 plus 10 is 12. 12 faces. It's made of pentagons. Now, there are more than 5 of these. We'll stop at 5. There's 4. The last one is called, well, it's got 20 sides. It's made up of rhombuses, or triangles, sorry. It's made up of triangles. It has 20 faces. Yes. It's icosahedron.
That's a big word.
Jake.
As a D&D player, I don't see these as like dodecahedrons.
I know you don't. You see it as a 20-sided die.
Yeah, I see 12 faces.
A 12-sided die, an 8-sided die, a cube, or a 4-sided die.
Why is cube
Cube is like, yeah, it's very unique. Very unique. All right. These are all called the 5 Platonic Solids. And as we go higher in math, we'll see these again. But for right now, we just got to write down their names. Okay, is everybody good?
No.
We have one thing left. And it's the only math of the day, like formulas, numbers. Okay? We good?
1 second.
No.
Wait, is that like a Wait, can you make one of those little pyramid things with right side triangle?
Can you make a pyramid with right triangles? And the answer is certainly you can. Right?
What's 4 times 6? 4 times 6.
All right. So those of you that play D&D or other games, so here they are. Here's your cube. Here's your 20-sided. Here's your a tetrahedron. Here's your octahedron. So on and so on.
Icosahedron.
All right. No more definitions. Now we come to the math part. All right. There was a mathematician a long time ago. Now it's pretty recently in general terms, meaning like only a couple hundred years ago. His last name was, it looks like Euler, but it's actually, it's a German word. It's pronounced Euler, like and then oil. Right? So Euler was this guy that came up with this. He's famous for going blind. No, that was Gauss. Never mind. Here comes the math. I need you to write this down, box 10. Each one of these letters stands for something. They're all capital letters. Richard, right? This is Euler's formula.
I don't like it.
Euler's formula says this. It says if you take something called F, add it to V, and subtract E, you always get the number 2. It is a very remarkable formula, and that 7th graders can comprehend very quickly. All of these 2 added, subtracted, you will only get the number 2. Not 1, not 5, not sometimes, but always 2. So let's write down what these stand for. Euler said this. He said, if you have a polyhedron, any polyhedron, doesn't have to be regular, can be any polyhedron, that if you take the number of, add it to the number of and subtract the number of, you will always get, please stop. If you take the number of faces, add it to the number of vertices, subtract the number of edges, it's not sometimes, always you get the number 2. That's for every shape up there that's a polyhedron. You will only get the number 2. Hey, watch the math. You ready? How many faces? 1, 2, 3, 4, 5. Vertices. 1, 2, 3, 4, 5. 5 plus 5?
10.
Edges. 1, 2, 3, 4, 5, 6, 7, 8. 10 minus 8?
22. No.
It doesn't matter which polyhedron I grab, I will always get to the number 2. The number of faces plus the number of vertices minus the number of edges, you will always get the number 2.
What is this useful for?
Yes.
Why did this guy take the time to just figure? How did he take the time to figure?
So mathematicians spend their life, if they're not teachers, they spend their life thinking. That's all they do is think. Like people build things, people make things, mathematicians think. And so a good mathematician notices patterns. And what Euler did was one day he's sitting around and he had this in his hand and he had this in his hand and he noticed this. And he said, well, that's a coincidence that I get to 2. Is it for all polyhedron? He proved it. Okay. All right.
I can't do that, dog. You're just sitting there and thinking.
So, what's the shape?
You.
It's kind of more a box than a cube, right? A cube, remember, all 6 sides have to be squares. So let's see, how many faces? This is generally hard. Tonight, you'll have to do it. So sometimes, if you have the shape of your house, hold your hand. So how many sides?
6.
So faces is 6. Okay. How many vertices?
8.
1, 2, 3, 4, 5, 6, 7, 8. How many edges? How many edges on the top?
12.
How many edges on the top?
4.
How many edges on the sides?
4.
How many edges on the bottom?
4.
4 plus 4 plus 4.
12.
Okay, well, let's see. 6 plus 8
14.
minus 2 minus 12.
1.
We get 2. Crazy. Works every time.
Wait, what is this useful for?
What is it useful for? It can tell you whether or not you have a polyhedron. Because the only reason you have a polyhedron is if this is true and vice versa. If you have a polyhedron, this is true. Okay?
So are you going to ask us to test and confirm this is a polyhedron?
You are 100% correct. If it's a polyhedron, now I don't even need to tell you. I can leave one of these off and you can do some algebra. For instance, if I can tell you the number of faces and the number of vertices, you can now tell me how many edges it has just by plugging the numbers in, doing a little bit of algebra. Tonight for homework, literally that's what you'll be doing. Okay, so this is our tetrahedron again, right? Faces, it's got 1, 2, 3, and then the bottom 4. Vertices, corners, 1, 2, 3. Oh, it's got 4 as well. Edges, it's got 1, 2, 3, 4, 5, 6. It has 6. 4 plus 4 is 8. 8 minus 6 is 2. Pyramids come in many different flavors. The bottom, the base can be any shape as long as it's a polygon. The next one, the last one you have on your paper is, what's the bottom? What is the bottom?
Pentagon.
It's a pentagon. They took a pentagonal pyramid and they chopped off part of the pyramid. This is called, you don't have to write this down, it's called a truncated pyramid. Hey, you go to the circus, it's what the elephant stands on. Okay? If you've ever been to the circus, they stand on truncated pentagonal pyramids. Okay, let's see if the formula even works for this weird looking polyhedron. How many faces?
1, 2, 3, 4, 5, 6, 7. Yeah.
How many vertices?
10.
Antonio already knows the pattern. 5 on the top, 5 on the bottom, that's 10.
15.
How many edges?
15.
5 on the top, 5 on the bottom, 5 on the sides. So 15. 10 plus 10 minus 15 equals 2. 17 minus 15 is equal to 2. True. See you later. Eleanor, any questions?
Nope.
Cool. Hey, sometimes, Eleanor, these can become challenging simply because you don't have the shape in front of you and your eyeball will flip around on you. Just try not to give yourself a headache when you do the homework.
Okay. Oh wait, actually, I do have a question. Tomorrow
Okay.
we'll talk about irregular.
Hold on, everyone's talking. I can't hear you.
Okay.
Try it again.
Okay. Tomorrow, are we going to talk about irregular polyhedrons?
Hold on, I'm trying to hear her and you're talking to me. All right, one more time, Eleanor.
Okay. Tomorrow, are we going to talk about irregular polyhedrons?
This year we will not. Do you know what an irregular polyhedron is?
No.
So that would just mean that the sides are not, they're the same shape, but they're just different sizes. So for instance, if you took a pyramid and you move the vertex left or right, one of the triangles would have to get slightly smaller than the other ones. That would be an irregular polyhedron.
Oh, okay.
Cool. We actually won't talk about irregular ones until we get to high school geometry.
Got it.
Okay. Anything else?
Nope.
All right. Catch you tomorrow.
Okay. Bye.